Assalamualaikum and hello everyone. So for today, my friend and I will be share with you guys the application of thermodynamic engineering in refrigerator. So I will start first with the description of the application. What is refrigerator? I'm sure that everyone already knows what refrigerator is. It's become a need in every house in these days. Its function is to cool down the food stored in it and to preserve the food and slow the growth of any microorganisms such as bacteria. It is to make sure the food will last longer. And this is the component which are compressor, condenser, expansion valve, and evaporator. So how does it work? It is actually because of the cycles of change of phase in refrigerant. First, the refrigerant gas will be compressed at the compressor, and then it will be turned to the high pressure and high temperature gas. And so the gas will be flow to the condenser, and at this condenser, condensation occur. The gas will be turned to liquid phase. And so the refrigerant liquid will be flow through the expansion valve. And at this expansion valve, it will lower the pressure and the temperature of the refrigerant liquid. And so after that, the liquid will be slowly turned to gas as the heat being absorbed at evaporator. And then it will make the refrigerator cooler. It become cool. And so the cycle will be repeated again.
My name is Zakwan Syahmi bin NOOR MOHAMMAD. My matrix number is 208064. Next, I will explain about first law of thermodynamics related to refrigerator. Before that, what is first law of thermodynamics? First law of thermodynamics is also known as law of conservation of energy. This law states that energy cannot be created or destroyed, but can only be transferred or changed from one form to another form. For example, like electrical energy changed to kinetic energy. This law also states that the total amount of energy must remain constant, which means the amount of energy before transformation is same as amount of energy after the transformation. So, based on first law of thermodynamics in refrigerator, the energy will start convert from electrical energy, which comes from the power supply. Then, the electrical energy will run a motor in the refrigerator that will cause the electrical energy transform into mechanical energy. Next, the motor will drive the compressor and it will heat the refrigerant. So, the mechanical energy will change into thermal energy. Lastly, the thermal energy in the refrigerant will be cooled back by condenser. The cycle of conservation of energy in the refrigerator will be repeated again and again because it is continuous. So, based on first law of thermodynamics, the equation that we can relate in refrigerator is change in internal energy in refrigerator equal to Q, heat which come from the refrigerant that heated by the compressor, minus W, work done, which is come from the motor that drive the compressor.
Assalamualaikum. My name is ZULFAIZ. Now I will explain about second law of thermodynamics related to refrigerator. So what is second law of thermodynamics? Second law of thermodynamics explain about direction of quality of the energy. So it means the heat will transfer spontaneously from high reservoir to low reservoir. Let's say at the example given, it contains the hot chamber and the cold chamber. The hot chamber contains the high capacity of heat and the cold chamber contains low capacity of heat. So the heat will transfer spontaneously without any external force to the cold chamber until the two chamber is in equilibrium. So the direction of the heat cannot be inverted from the cold to the hot chamber except it contains work. Work is required to make it is possible. So let's say at the example, it is possible to water to lift up at the height chamber. So it is possible because related to first law of thermodynamics that's explained about energy will conserve from initial and the final. So this law is applied at the refrigeration cycle. As we can see at the condenser coil, it contains the high temperature. So the high temperature contains high capacity of the heat. So the heat will transfer flow at from the coil to the hot room. So when the refrigerant at the evaporator coil, it contains the low amount of the heat. So the heat from the cold room will absorb at the evaporator coil, and it will throw away the heat at the hot room again in the cycle.
So next, we will explain about thermodynamic analysis in refrigerator. As we know, in refrigerator, it have four major components that involve in refrigerator system cycle, which are compressor, condenser, expansion valve, and evaporator. All of these components have analysis about thermodynamics. The first component is compressor. Actually, the compressor is driven by electric motor. The refrigerant will enter the compressor as saturated vapor with low pressure and low temperature. The compressor will compress the refrigerant that causes the molecule collide to each other in small volume. The temperature and pressure of refrigerant will increase. Based on my knowledge in thermodynamics, the energy balance equation in compressor is as shown in figure above. Work in plus mass flow rate in multiplied by enthalpy 1 equal to mass flow rate out multiplied by enthalpy 2. So the energy balance equation has work in because the compressor is driven by electric motor.
Now we see the second analysis of the refrigerant, which is condenser. The condenser will have the high pressure and high temperature of the refrigerant. The refrigerant will flow through the condenser coil and release the heat. That's why the equation of the condenser only contain the Q out. So the Q out explain about the heat that release.
So I will continue with the analysis of the expansion valve. So this is how it looks in expansion valve. Expansion valve is used to lower the temperature and the pressure of the liquid refrigerant. And after it flow out from the expansion valve, it will produce a low pressure, low temperature saturated mixture of refrigerant. It is to make sure that it can be turned easily to gas when it flow through the evaporator. As the gas itself, the mixture itself absorb the heat, it will be turned to gas in evaporator. So this is the equation. It is very easy because there's no work, no heat transfer, and also there's no potential energy and kinetic energy. So we can cancel the Q, the W, and the potential energy and the kinetic energy. And this is what left.
The last analysis of the refrigerant is evaporator. Evaporator contain high pressure and low temperature of the refrigerant. So the refrigerant will flow through the evaporator coil and absorb the heat. So that's why the equation of the evaporator only contain the Q in.